task and function, right? So the use of the task is for what? Reusability, and then you can break the complex program into the smaller programs and then more manageable section. You can call the task and function many times. And then if you look at the differences between the task and function, what is the difference between the task and function? Task will execute at non-zero simulation and function will execute zero simulation. Task may have zero or more number of input and output arguments, but function at least should have only one input, and the function will returns the value. Task does not returns the value. And then other differences is task can allow the what? Delays, timings, events, where function does not allows the timings, delays, and events. So most use of this task and functions are recommended to use in the test benches to modeling the digital circuits. Correct. So yesterday we were talking about one program. Correct. If you see the syntax of the task, how you write the syntax of the task? Start with what? Task. Correct. Followed by what? Task name. Correct. Then you are declaring the input, then output. Then you are writing the statement within the one, begin and end. So these are statements of the task, correct? Statements. Then you need to end the module in the task. So task, where you can read the task? Where you are reading the task? Task writing inside the one. It is local to the module. These task variables are interfacing with the what? Module variables. Where module variables can be interfacing with the user-defined inputs and inputs, and then out to the external world. So whether I can use inside the task, whether I can use initial begin. Inside the task, whether I can use the initial begin. Inside the task, initial begin means procedural blocks. No. So when you want to call the task, you can put inside the one, initial and always. Correct. Task can call the task. Correct. Task can also call the function, but function can calls only the function, and function does not calls or invoke the task. So these are few differences we saw in the task and function, and we worked with few examples of the task and functions. Correct. So we are working on full order, right? Full order using half order. Full order using half order. Your task using task, right? Using task. So how to write the full order using half order using task? So full order is a module, correct? Module. And what is the module name I can give is full order. So what are the inputs to this? A is the input, B is the input, C is the input, sum is the output, C out is the output. Correct. So here what are the inputs? Input are A comma B, Ci, then output are someone can. Output is output. I can call reg, correct? Reg. Someone can. Sorry, this is C out. Someone C out. This is a full order model. Now what I want to do? I want to design the full order using half order using task. Now I should write the task, right? Task of the one. Half order. So how to write a task? Task keyword. Name of the task. Correct? Then I can write like this, right? Inside. Input. Shall I write data type is input? A comma B and then output. Output range is what? Someone can. Let us select someone C. S and C are the outputs. Next, what I need to write? We need to write a statement, right? How to write the statements? Begin and end. Before that, writing the statements, begin and end. Sum is equal to what is the half order expression is? A XOR B. C is equal to what? A and B. A and B. Then end the task. So end the initial, then end the task. End the task. Correct? This is a task for what? Half one. Now I need to call this task. Correct. How to call this task? Always at the rate or A comma B comma C A, is it fine? Or A or B or C A is also fine. Correct. I can write A or B or C A. Then begin. Then begin. Then what I need to do? What I need to write? Name of the task. What is the name of the task? Is half order. So order. How many half orders are required to represent the full order? 2 half order, 1 OR gate. Correct. So how to write the 2 half order? Half order. Correct. So I need to declare the whites right here. So I need to declare this as a what data type? White data type. What are the whites are? Shall I take S1 comma C1 comma C2? Did you understand? Then what I need to write here? Full order output is S1. I am writing first inputs and then outputs, right? Shall I change first this into what? Output. I am going to change this into the output. Then I am going to write the input. Did you understand? Now I am writing the output, half order. Sum is connecting into what? S1. C is connecting into what? C1. If you remember the half order, full order using half order. First half order, what are the inputs, sir? A and B. Then, again I am going to call this task. Then what are the output is? Sum, right? Then C2. Then S1 comma CA. S1 comma CA. Then what I have? C out. C out is equal to what? I can write C1 or a gate of C2. Correct? Now I am going to now what I need to do? In the module. So this is a design file we are writing. Using task we have built the full order. So in the full order, so I should declare this as a rich data type. Did you understand? Now this is a full order using half order. Now what I need to do? Now let us write the test bench. This is a design file. Now let us write the test bench. What is the test bench is? Module, DB, then registers are all A comma B comma C, then whites are S1 comma sum, right? Why output is what? Sum comma C out. Sum comma C out. Now I need to instantiate this full order. So let us instantiate this by using name. I am going to enchant this by name A of what? A and dot B of B and dot CA of CA and dot sum of sum. And this is dot C out of C out. I am enchanting the full order. So next what I need to do? Initialize the values of what? A comma B comma C. This is equal to dollar symbol random. Then let me give some sim time. Now I am going to display it. Display of what? Let us display A is equal to correct. Dollar $B comma B is equal to dollar $B and then CA is equal to dollar $B and then sum is equal to what? Dollar $B percentage B. Then C out is equal to percentage B. Then this is A comma B comma CA comma sum comma C. Then I am going to end this. Then I am going to end the finish. Then I am going to end the initial begin. Then end the module. Correct. Now let us run this program. So when A is 1, B is 0, C is 0, sum is 1 and then carry is 0. Correct. Now let us repeat this for 5 times. Repeat of 5. Begin. Then before finish, I am going to end the repeat. End. So these are the 5 inputs: A0, B0, C0, A1, B0, then C0. What is sum and carry for this combination is 1, 0, 0, sum is carry 0. 0, 0, 1 is sum is 1, carry 0. 0, 0, 1, sum is 1, carry 0. 0, 1, 1, sum 0, carry 1. 1, 0, 1, sum is 0, carry. So this is how you can build a what? Full order using half order using what? Task. Now you can think of the program how you can write a parallel 4-bit parallel order using what? Using full order. Full order using task. Okay. So this is one program we discussed in the last session, correct? So this is a task. You know how to declaring the task. What is the syntax of the task? Then what is the considerations you should make true to work with the task? What are the points you should make when you are writing the task? Task will allow the delays, timings, events. Task will execute non-zero simulation. Task can allow 0 or more number of arguments. Task cannot return the values. Did you understand? Task can call the task and also the function. So this is the example of the task. Correct. Now we understand how to use the task, how to write a task. So this is a program already we discussed in yesterday. So we are finding the bitwise OR operation, AND operation and XOR operation. This is an input module. We are declaring the input and parameter. So here I am calling the task. Here we are writing the task here. Task name, outputs and inputs. So we are writing the expression. And bitwise AND operation, bitwise OR operation, bitwise XOR operation, end task. Then I am calling the task here. Correct. This is one example. Now your task can be also used for calling the initialization of value also. Let us take in this example. Task can directly operate on the register variables which is defined in the module. So here this is the program which we are generating the asymmetric sequence generator. What do you mean by asymmetric sequence generator? Random value, that a random sequence generator. So this random value sequence generator we have generated using the task. Understand this program. So we are defining the module. What is the module name is sequence. Then clock. Clock is defined as a reg. Then initial begin. In this initial begin, what I am doing? I am invoking the task. What task is? This task. This is a task of what? Initialization of the sequence. Task, what is the task name I am writing is initial underscore sequence. So there is no arguments to this task, right? Task should allow what? 0 or more arguments. There is no argument to this. In the begin, what I am doing here? I am initializing the clock to what? 0. So this is a one task I am writing to initializing the what? This is the initialization of the sequence. Means clock is equal to 0. And then in the next line, what we are writing? It is used to generating the asymmetric sequence. Task, what is task name is? Asymmetric sequence. Then these are the statement, begin and end. At what time we are writing? At 12, clock is equal to what? 0. And the next time simulation time is 5, clock is equal to 1. Clock at time 3 is nothing but clock is equal to 0, 10 is nothing but clock is equal to 1. Then we are calling the clock here. So in initial begin, which task I am calling here? We are calling the task here. In the initial begin, I am calling the what? This task. So which I initializing the sequence. In the this task, what I am calling is to generating the what? Asymmetry. Always begin asymmetric sequence. This invokes the task asymmetric sequence. So I am writing the two tasks here. One task is used for initializing the clock. Second task is using for generating the what? Asymmetric sequence. Did you understand? Now I am writing the dollar display to this. Let us run this program and show you. So this is a program. You can see this is a task. we are writing, let me copy this program. Did you understand this program? So this is a program. This is a module name register. Then this is the monitoring the value of what? Clock. So here I'm calling the task in the one initial begin where I'm initializing the sequence. This is another task I'm calling here in the always block, which is creating the what? Asymmetric sequence. Now we are writing the task. This is a task we are initializing what? Clock to 0. So this is a task we are generating the what? Random, we say asymmetric sequences. Now what is the output I'm going to get? What is the output of this? At time t is equal to 0, clock is 0.
मैं खुद बना दूं तो मेरे को दे दे एक दिन तक बनाने के लिए
clock is 0.
लग मुझे दे एक दिन बनाने के लिए मैं बना दूं
5 is 17. At 17 clock is equal to 1. 17 plus 3 means what? 20. At 20 clock is equal to 0. Then 20 plus 10 means 30. At clock is equal to 1. Again I'm putting this in the always block until it encounters what? Finish. It will keep doing. Now I'm monitoring the values here. Dollar symbol monitored. So this is the output of this program. So there is a line number. I'm not done the what? In the module. It has to end the module. Let us run this program. You can see at time t is equal to 0, clock 0. But I'm not getting at time t is equal to 12. Why I'm not getting? Since I'm using the dollar symbol monitor. What dollar symbol monitor will do? When value changes, signal value changes only it will monitor. But at the time 12, what I have value is 0. At time t is equal to also what? 0. So that it is not monitored. So at what time again it is monitoring? So 12 plus 5 is nothing but what? 17. At 17 clock is equal to 1. Then 17 plus 3 means what? 20. 20 at clock is equal to 0. Then 20 plus 10 means what? 30. The clock is equal to 1. We have generated the what? Sequence. Asymmetric sequence. Clock. Correct? Did you understand? So here I am using two tasks. One task is for initializing the value. Another task is using for what? Asymmetric sequence generation of the clock. Correct. So this is a one example. Now let us understand what is meant by automatic task. What is meant by automatic task? We call that is nothing but re-enter into task. What is mean by re-enter into task is when you are calling the same task concurrently. What is the meaning of this? Parallelly you are calling the same task. Concurrently you are calling. If I am using the task, I am calling this concurrently, the result will be not correct. Why? Because you can see what is meant by automatic or re-enter task. And then we'll understand writing a program, we'll see how it is producing the incorrect output and correct output. So task basically they are static in nature. What is mean by static in nature is nothing but whatever the variables you are using in the task, input variable and output variable will be based upon the size, it is going to statically declare it. Means fixed size it is going to declare. Okay. So all declared items are statistically allocated and they are shared across all the users of the task when they are executing concurrently. So by default in this program, see here I am using what? Task, right? Task and some variables I am using. These variables are declared as static in nature. So what is mean by this static in nature means all the declared items are statically allocated. Means all these variables are allocated with some memory, static memory, fixed memory, or fixed size of memory. And they shared across all the users of task when executing concurrently. Therefore, if the task is called concurrently from the two places, so I am calling the same task in two places. Concurrently I am calling, same time I am calling this task. And at the same time I am calling the task. Concurrently I am calling the two tasks, two places in the code. This task calls will operate on same task variables. What happens here is nothing but if I am calling the task concurrently in the two places, same task, both the tasks, when I am calling, it is using the same variable. of the task, correct? When you declare the task, all the variables which is declared as static in nature. So when you call the task, in two places you are calling the task, this task calls will operate on the same variables of the two task variables. Means first I am calling that, this is also operating on the same variable of the task. And second I am calling concurrently. This is also what? Calling the same variable of the task variables. So it is highly likely that results of such operation will be what? Incorrect. When the same task is two places concurrently if you call, this will use the same variables of the task. So what it will do, it will result the what? Incorrect output. To avoid this problem, we'll go with what? Keyword call it as an automatic. So automatic keyword is added in front of the task keyword. Make sure that task will be becomes what? Re-entering, or that becomes what? Automatic task. What this automatic task will do is nothing but it will do the dynamic allocation of the variables. Rather than allocating the static allocation, it is going for what? Dynamic allocation. So how dynamic allocation will do is nothing but it is like a non-blocking operation. How non-blocking will be executed? Right hand side will be evaluated, that will be stored in what? Internal local variables or temporary variables. That will be right into the left hand side variables. So when you use this automatic, all these variables will be dynamically allocated. So in this case, what happens in such task? Whenever you are using task, after writing the task, before your task name, if you write the automatic, all your variables of task will be dynamically allocated. Did you understand? So let us take an example to this. So what is this? Means all the items declared inside the automatic task are allocated dynamically for what? Each invocation. So each task calls operates on in an independent space then. It is allocating dynamically to the task variables. When you are calling the task, the call operates in the independent space now. Did you understand? So thus the task calls operate on independent copies of the task variables. This results in the what? Correct operation. This result in the correct operation. So when to use this automatic task is nothing but when you are calling the task concurrently in the two places. Result will be incorrect always. To avoid that, when you have a situation that where you are calling the task to concurrently in the two places, result will be incorrect. To avoid that, what you can do? You can go with the automatic task where now it is when you are calling task, it will taking the independent space of the task variables. In first case, if you take a task and calling the without the automatic, same variables will be used at what? When you are calling two places. Now what happens in dynamic means it is dynamically allocated. This will be works on independent space. When you are calling concurrently, so same variables you are using but dynamically you are using. Did you understand? So it is recommending that automatic task can be used if there is a what? Chance that task may be called concurrently from the what? Two locations. Did you understand? So when you use the keyword automatic, the task variables are what? Dynamically it is created. Dynamic means when you are calling concurrently, it is now it is working as an independent space. Are you understand? Now let us see this example. So we are writing the automatic re-entering task here, automatic task here. So module name is top, and reg I am declaring the what? Variable as cd underscore xr and ef underscore xr, and then reg 15 down to 0 means 16 bits. It is cd ef are the inputs. I am using the reg class. Now we are writing the task here. Task. Let us forget about this automatic now. Task name is what? Bitwise XR operation. Then we are declaring the inputs AB XR. Then AB are the inputs and outputs here. AB underscore XR is the output 16 bit and input is nothing but AB. Now begin. So we are indicating with the time. Then I am performing the what operation? XR operation. AB underscore XR is equal to A XR B. Now end and end the task. Now this task is calling concurrently in the two places. See, one always at the positive edge of the clock and using what? Task name. What is the task name is? Bitwise underscore XR, and this output variable and this is input variable. And one another always block, always at the positive edge of the clock, I'm calling the same task. So this is like I'm calling the task concurrently in the two places. Same time I'm calling. This also executing at time t is equal to 0. This also executing at what? Time t is equal to 0. So if these tasks are dynamic statically allocated here, so when you're performing the bitwise operation, it will lead to what? Incorrect result. How to make the automatic task this to avoid this? Then you can use the keyword after your task keyword. Use the keyword is what? Automatic task. Now these task variables are what? Dynamically allocated, which are an independent space now. So when you are calling also, it will use the what? Correct result. Did you understand? So when to use the automatic task? Recommended to use the automatic task. If there is a chance of task is calling two places concurrently, in such case, task variable should be what? Declare as a dynamic variable, dynamic declaration, allocation, then you can use the what keyword? Automatic keyword. It is not recommended to play in all the places you can use the automatic task because this dynamic allocation requires extra memory. Did you understand? Where there is a chance of calling the task in two places concurrently, then you can go with what? Automatic task. Now let us run this program and see without a task, without automatic, with automatic, what output it is going to give us. So what is the task we are writing here? This program. Did you understand this program? What is this program is? We are doing the bitwise XR operation. How many bits is? 16 bits. Using task, we are writing the bitwise XR operation. Then we are calling concurrently 2 times. Did you understand? Now let us analyze this program by running. This is automatic task. So same program I'm using the clock so that I will be generating the clock. Then I'm printing the output. So let me recap this program again. So this is the module. These are the variables which is declared as a rate 16-bit. CDF are the inputs which is declared as a 16-bit, and the clock initially declaring as a 0, range 0. Now here I'm calling the task, always at the positive edge of the clock. So here also I'm calling the task. Two places, same task concurrently it is calling. So this always block will start executing at what time? T is equal to 0. This also start executing what? Concurrently it is executing. In two places I am calling the task. Correct? Now this is a task we are written for what? XR operation. Did you understand? Then, so I am generating the what? Clock. Because always at the positive edge of the clock I am using. But always #5 clock is equal to not of clock. This is for clock generation. Now I am using always at the positive edge of the clock. So I am assigning the E and F value, random value. Then I am calling the what? Sorry, this is I am calling 2 times. Okay. So this is a one time I am calling here. Okay. So let us remove this. I am going to remove this here. Okay. Since I have called here, always at the positive edge of the clock begin. I am initializing the E and F value, $symbol random. Then I am calling the task. Correct. What is the task name I have given is bitwise underscore XR. And then in this also I am calling the task CD, and I am calling it as okay. #5 is then nothing to worry. Here also I am calling the task. Now this initial begin I am going to monitor the value. Did you understand? Now in the task, when I am writing the task, let us remove this automatic task here. Remove the automatic task. So this task is concurrently calling in the two places. Correct. Now you can see what is the output of this program. So this is executing at t is equal to 5. At t is equal to 0, I am writing here in the in the always block I am writing #5. Okay. So this is the output at t is equal to 5. You can see what operation we are doing is nothing but XR operation. Correct. Whereas we are doing the XR operation, let me copy this result. Let me copy here and we'll analyze this. So I'm using what task?
फल खा लिया
What task I'm using? Without
खा लिए गाजर खा लिए
without automatic, correct?
हाँ,
So let me copy, this is C and this is nothing but D and this is nothing but E and F.
खाने की चीज तो
E and F. What operation we have done is nothing but XOR operation. Let us verify this result.
आज हवा निकल रही है
So this is a result. When C is equal to, okay, let us write like this. This is C and this is nothing but D.
ये सब बना हुआ सब्जी
What is the XOR operation?
सब सर्दी की वजह से
So 0, 1 XOR operation is nothing but what? This should be 1, right? 0, 0 is 0. So 1, 1 is 0. Again 0, 0 is, it is giving 1. Whether it is giving the correct output? No. Now here also you can see what I am using. XOR operation, I am calling the two places. Same task calling in the two places. This also results what? Wrong operation. So 1, 1 is 0, okay, 0, 0. Here 1, 0 is nothing but what? 1. Did you understand? So this gives me the incorrect output. So now what I am going to do? So I am going to make this into what? Since I am calling the task in the two places concurrently, so that I want to allocate the variables of the task into one. Dynamically it should allocate and it should now has an independent space. Now I am going to give it, keyword is nothing but what? Automatic. Did you understand? Now all these variables which I am using task will be what? Dynamically, which is allocated on independent space. Now let us run this program. Now can you see this result output? Let us copy this result. Now you can understand this output. This is CD, CED, and this is E and F. Now can you verify this result? XOR operation. Is it doing XOR operation E and F? 1, 1 is 0, 0, 0 is 0, 0, 0 is 0, 0, 1 is nothing but 1, correct? 0, 0, 0, again 0, 0, 1, 1, 1, 1, 0, 0, 1. Now it is doing the XOR operation correctly. Now you can see this is nothing but what? So 0, 1 is 1, 0, 0 is 0, 1, 1 is 0, 0, 0 is 0, 1, 0 is 1, 0, 1 is 1, 0, 0 is 0, 0, 1, 1, 1, 0, 0, 1, 0, 0. Did you understand what is meant by automatic task and or we call re-enter into task using the keyword called what? Automatic. Did you understand? So it is recommended to use what? It is recommended that automatic task can be used if there is a chance that a task might be called concurrently from the two location in the code. Is this is clear? What is meant by automatic task, re-entering task? Okay. Now let us go to the next. Now we understand that how to write a task, correct? How to write a task and how to call the task. So when you are trying to call the same task in two places concurrently, what is the problem? How to avoid that problem? So you can go with the automatic task. Now let us go with the function. What is a function in Verilla perspective? What is a function? Function are used for what? Reusability, correct? For the efficiency call, we can call the function in the multiple times. In Verilla perspective, function will execute at non-zero simulation time. Function does not allow timing events and delays. Function at least have one input argument. Correct? Function returns the value. Function calls only the function. Function does not call the task. So what is a function in the Verilog is functions are declared with the keyword function and end function. Functions are used if all the following condition is only true. Correct? What are the condition is true for the function? Function, there is no delays. there is no timings, there is no event control constructs in the function, or a procedure is nothing but a function. Did you understand? The function returns the what value? Single value, and there is at least one input argument to the function. Function will execute at what simulation time? 0 simulation time. So these are keywords are used to define the function and end function. If you look at the syntax of the function, so this is how you can declare or invoking the function. It is start with what? Function declaration syntax is function. Keyword start with what? Function, and then name of the function. Then you can type the what? Range or type of this name of the function. So range or type. What is the range? It is 7 down to 0. What is a data type? It is reg data type, integer data type, etc. If you are not mentioning this range, by default, this will takes what? Scalar. Well, scalar means what? Single value. So function followed by what? Range or the type, then followed by what? Name of the function, then start with what? Function declaration, then statement of the function. If multiple statements are there, you should group it what? Begin and end, then end the function. Then end the function. So the range or type may be, how you can write the range or type is, the range like 7 down to 0, 15 down to 0, range you can specify, and type may be what? Integer, real, and then how to call the function. So name of the function you should write using what? Identifier. You should follow the rules. How you are writing the identifier. Use the same rule to write the what? Name of the function. Function, okay. Function keyword followed by what? Range or the data type followed by what? Name of the function. Then begin and end. Write the statements. Then what you need to write? End the function. Did you understand? Then how to write the function name is nothing but using identifiers. The rule you are following to write the identifier. This is a function declaration. Then how to invoke the function? How to invoke the function? How to call the function? By using the function name, right? By using the function name. What is the name of the function? Use this name of the function. So this function returns the value to the where? Where it is going to return? Function will return the value, right? Function returns the value to the what? Name of the function. It is going to return the name of the function. But task does not return the value. Did you understand? Now when function is declared, a register with the name of the function is declared implicitly inside the Verilog. Means whenever you declare the function with the name of the function, this name of the function will be declared implicitly inside the Verilog. Implicitly it is declared the Verilog. Then if you specify the range, then according to that range, it is going to declare the, implicitly it is going to declare the range with the name of the function. Did you understand? The output of the function is passed by setting the value of the what? Register. What is a register? Is nothing but a name of the function appropriately. Did you understand? If you are declaring a function, a register with the name of the function will be declared implicitly in the Verilog. Did you understand? You are declaring the name of the function, like let us take art, function art. Now it is going to be declaring as a register for the art. So I am not specifying any range. So that what is a range is nothing but single, scalar, single value of the art. If I am specifying 7 down to 0, it is going to implicitly declaring the register. The depth of that, width of that is nothing but what? 8 art. Did you understand? The function is declared. The register with the name function is declared implicitly inside the Verilog. So the output of the function will be passed back to where? Passed back to setting the value of the where you are passing. This is nothing but name of the function appropriately. Because function returns the values. Did you understand? The function is invoked by specifying the name of the function and input arguments. So at the end of the function execution, the return value is placed where the function was what? Called. So at the end of the function execution, it is going to return the value placed where the function is invoking means calling. Did you understand these points? How you can declaring and invoking the function, how it will work. Now, if you are not using a range underscore type, so it is also range underscore type specifies the width of the internal register. If you are not specifying this range or a type, what is the width of the internal register is? If the no range or type is specified, the default bit width is what? 1. Means scalar. It is making a register implicitly inside Verilog. It is going to create what? Width of 1. So like these functions are very similar to the functions which are in Fortran language. It is 40-50 years.
गलती तो आपकी है वो ये एक एक रोटी खाना चाहिए मिला मिला के तब आप बनाते हैं उसमें प्योर मक्खन प्योर बाजरी मिला मिला के खाना चाहिए अच्छा जैसे करूँगी वो करूँ
रोटी बनाऊंगी
तुम्हारी बात
और बैगन सिखा के लहसुन छिल के रखना
तो सबका
दूध का बात मत करना आज रे
मेरे लेवल का हिसाब है ऐसे नहीं
नहीं दिखेगा ना रोज रोज इतना खा रहे हैं उसने बर्बादी कर दी
ये भी क्या नो आदमी है तो नो अंडर लेता है के बना लेकिन पर डे ये ना ये करना पर डे
हां तो नुकसान नहीं करता है ज्यादा खाना भी नहीं होता है नुकसान नहीं जनाब के अंदर जल्दी ये भी खा दिए इसका इतना खा दिया हो ढक दे कोई कपड़ा से उबाला करने रख दे फ्रिजों में रखते माना कर फ्रिजों में रख के आगे ना रहे पागल तो कहाँ रख देंगे
याद ही नहीं है यार
खाने वाला चीज है, अभी तुरंत खाने वाला चीज के लिए नुकसान करेगा। ये बस दो घुमाती के खाली रोटी के बाद
This conference will now be recorded.
The question is, so write a program using function. Program using function. Do the right shift and left. Right shift and left shift. Right shift and left shift. How to write a program to this? Okay, module. Let me comment this line. Okay, module. Okay. Okay, module TB. Right. 15 down to 0, correct? Address, RA. Okay, let us take address. Then, wedge control, okay. Wedge control. Okay, then. So, to do right shift and left shift, you can use any compiler directives. Tick define, left shift. Left shift means you make what I need to make. One tick B1. Define a text macro using tick define, and you can use that inside your program. Okay, first you write what you can understand, then you can later you modify that. Use the compiler directives. Then what I need to do? Okay, function. So this is reg, right? Reg is 15 down to 0. 15 down to 0. Then name of the function is, let us take shift. Okay, then input reg 15 down to 0 of reg or reg 15 down to 0? Reg 15 down to 0. Let us take ADDRESS. I'm using different variable. Okay, next. Input reg control. Reg control. Okay, then. Okay, begin. And then end. Let me write the end function also. End function. So what is the statement I can write? Any equation, any operators are used to do this. Now, what my question is, if my control is 0, I should do what? A shifting operation. Left shift by 1. If control is equal to 1, left shift, control is 1. Control is 0, do the right shift. How to do this using? What operator I can use? One way to do is ring if statement. Or you can use the ternary statements, conditional statement. Conditional statement, correct? So what is a conditional statement is? I can write control, right? I'm writing the expression to the conditional statement. Control is equal to 0. This is what? Colon. What I want to do? If control is equal to 0, if control is equal to 1, true function will be evaluated. Sorry, this is question mark, right? Question mark and colon. If this is true, what I need to do? Left shift. Control is equal to 1 means left shift. So what I want to do? Address, correct? What is the left shift operator? Address of 1. Correct? When this is control is true, I'm doing the left shift. Control is equal to 0, it is going to what statement? False statement. What is false statement is? Address, right shift by what? 1. Did you understand? I'm writing control is 0 means what? Right shift. Or then I should do, this is a true statement, right? This is a true statement. When control, if control is equal to 0 means what? 0 is equal to 0. Then that becomes what? True statement. True statement means I should write here what? The right shift. Correct? Yeah. Now when control is equal to 1, 1 is not is equal to 0, then what shift I need to do? Left shift after shift. Left shift. You don't understand? Then what I need to do? I need to write this into what? Return this into what? Shift is equal to. Correct? Now what I want to do? Call the function always at the rate of what? ADDR or control? Control. Control. Then what? Begin. So here also I am using control, here also I am using control. So I can write here I am going to write what? CNT. Here also I am going to write what? CNT. Now if control, always at the rate control, begin, what I want to do? What I want to do? I need to call the function, right? How to call the function? This is a function name, right? How to call the function name? Function name. Here, ADDR is equal to ADDR means this is the input I am using here. I need to initialize the ADDR 16-bit, right? If I have a 16-bit, I should do what? Right shift operation. I need to assign the value to the ADDR, right? 16-bit. So I can use one more variable here. Let us use range 15 down to 0. Let us take out. Correct? Now I can write what here? Out is equal to what? Shift off address. Then what I need to do? What I am writing the function here? Address of control I should write, or address of shift off address comma control I should write. You can see here, this is the parity. Okay, let us come to this program. This is a function we are writing. Function, here I am taking the 32 bits. Function 31 down to 0 shift. Then input is address. Another input is what? Control. Now by default, this address will take how many bits? 32 bits. This control will take what? 1 bit. Now we are writing what? Conditional statement. Control is equal to 1. I am defining this using what? Compiler directives, macros, text to macros we have created. Tick defined left shift is equal to what? 0. Tick defined right shift is equal to what? 1. Control is equal to tick left shift. When this is equal to 0, control is equal to 0, what it is going to do? Left shift operation. Address is less than 1. If it is false, it is going to do. Address is greater than 1, means right shift operation. Now I am ending this in the begin and in the function. This is a function we are writing. Now coming to this, I am declaring the 32-bit address. 32-bit what? Left underscore address. 32-bit right underscore address. Now always at the address changes. Always at the address. Now I am calling the function. Or how I am calling the function? First left underscore address is equal to what? What is the function name is shift of address comma what? Left shift. Then again I am right shift. Right underscore address is equal to shift of what? Address comma right shift. Did you understand? Now this will make what? Right shift and the left shift based upon this left shift and the right shift operation. So this is a program. It has run this program. So we are assigning the values of the address of the 32-bit. So this is a module and we are defining the variable. So this I should define variable out of the module scope, right? Then I am writing reg 32 address, left shift, right shift, control. Then I am initializing and monitoring the values. Then here I am writing the function. This is a function we are writing. This is a function and we are calling the function here and we are monitoring the output. Now let us run this program and see how this is working as right shift and the left shift. Now you can analyze this output. I am monitoring the values here. At time 1 I am putting address is equal to this address 32-bit. Again time 10, 20, 30 and 40. So this is executing at time t is equal to 1. This is at time 11. Correct. This time 21, 31 and 40. So this is the output of this program. Let's keep this here. At time t is equal to 0, address under left underscore address, right underscore address, all the address data will be what? Unknown. And time t is equal to 1, it has to do what? Right shift operation. So this is a number, this is a right shift operation. So this is a left underscore address and this is a right underscore address. This is the address I'm giving. So it is shifted by how much? Shifted by 1. So to understand this, let us make this into 8 bits so that you can easily understand. 7 down to 0. So let us make 7 down to 0 means let us assign only one value. This is 8 tick. Let us make A or 0A. 0A or let us make to easy understanding of this. Okay, let us make 0A. 0A. Then here I am going to declare 7 down to 0. Here also I am going to declare 7 down to 0. So let us remove this and run this program.
ये लाइट कट गई है।
हाँ हाँ ले लिया।
लाइट कट गई। लाइट कट गई।
This conference will now be recorded.
This is what? Right shift, right? If you do the right shift, what happens here? This one shifted here, this one shift here. This becomes 5. 10 is right shifted by 5 means what? Divided by 2. This becomes 5. And 10 is multiplied by what? 2. Left shift. Now this becomes what? 20. Did you understand? Did you understand this? How you can write the function here? So I am using what operator is ternary operator. If this is true, this statement will be executed. If this is false, this statement will be executed using function. So here I am calling the function for what? Left shift also the right shift. So here I am declaring the monitoring here. Here I am declaring the variables. I am using the compiler directives with the tick defined, I am creating a text macro. If left underscore shift is what? 0 means I should do the left shift operation. This is 1 means right shift operation. This I am using here to write the control statements, and here 0 means left shift, 1 means right shift. Did you understand this program? Okay, this is one program. Let us write a one more program using function. Let us copy this program here. Can you see this program? Next one. So this is an example for parity calculation. What parity calculation is nothing but whether it is having a even parity or odd parity. How to check the even parity and odd parity? What operator you can use? How to check the odd parity? XOR operation, even parity, XNOR operation. Now using function, I want to write the parity calculation. If I give the bit 8-bit or 16-bit to you, whether it is even parity or odd parity, using function. Now let us see that how to write the function first. Function, the function name is nothing but what? Calculate underscore parity. By default, this will be declaring the size of what register? 1-bit register. Correct? Now calculate underscore parity will take how many bits? 1 bit. Range is nothing but 1. Now we are declaring the input with the address, 32-bit address. Now we are using the begin. Now we are calculating the one parity. So result will be, output will be returned to the function name. Calc underscore parity is equal to what I am doing. This is reduced bitwise operator, right? So what is this power symbol indicates? XOR operation, XOR underscore address. It returns the XOR of all the address bits. So XOR is using for what parity checking? Odd parity checking. XOR. So now I am going to end the function, end the begin and end the function. Now I am getting the module name is parity. I am declaring with 32-bit address, then 1 bit with the parity. So then I am computing, I am calling the function name, always at the rate of what? Address begin. So I am using parity is equal to what? Parity is equal to calculate underscore address of, calculate underscore parity of address. Then I am printing here. Display parity calculated is equal to percentage B. Then calculate underscore parity. I am calling and this will be assigning to the what? Parity. Or here also I am calling the what? Function. Here I can use, instead of this one, calculate underscore parity of address, I can use what? Parity. Did you understand? Now this program will check for what? Odd parity. Odd parity. Did you understand? Let us run this program. We declared, we are calling the function here, then getting the function here, then assigning the value of what? 32 underscore initial begin. Let us remove initial, we are assigning the values of 32-bit, then getting the module.
This conference will now be recorded.
8-bit, 8 tick off. A, if I am giving input as A, it is even parity or odd parity. A is nothing but what in binary? 1 0 1 0. Again 1 0 1 0. What is the parity calculated is? 0. It should be 0. Correct? If I am using AB, A is nothing but 1 0 1 0. B is nothing but 1 0 1 1. So this is nothing but odd parity. Now it should give the parity calculated is what? 1. It is calculated as 1. So we are checking the parity, we are writing the one function. even parity or odd parity. Did you understand this program? Now, in similarly, what we talked about, automatic task, correct? What is the use of the automatic task is? Or re-entrant task. What is the use of the re-entrant task? When you are in two places, when you are calling the same function or task concurrently, they always, because when you are using a task, it is all the variables are statically allocated. There is no independent space for the allocations. So that it yields a result of what? Incorrect. To avoid that, we are using what? Automatic task. Similarly, in function also we have what? Automatic, or we call, in terms of function, we call it recursive. Automatic function or recursive function. When you are calling the concurrently in the two places, it yields the incorrect result. To avoid that, we are going with the what? Automatic function. How you can use automatic keyword is? Where you can use? After task or function. Function, space, automatic, then range or type, then function name. Did you understand? If a function is called concurrently from the two locations, the result are what? Non-deterministic, means incorrect. Because both the calls operated on the what? Same variables. The keyword automatic can be used to declare the what? Recursive functions also. What is meant by recursive? Functions, calling the function itself is nothing but what? Recursive function. To do its own job, it's calling the function itself, we call it as what? Recursive function. Okay. So in such cases, you can go with what? Automatic function. So where function declares are allocated, then when you use the automatic keyword, the function declaration happens at what? All the declaration will be how it is declared. Variables are declared dynamically. Did you understand? Like the way you discuss the task with automatic, in functions also, in two places concurrently if you call, result will be non-deterministic. To avoid this, you can go with one. Automatic task. One use of this automatic task is nothing but we call recursive function. What is meant by recursive function is nothing but calling function itself to do its own job, that we call it recursive function. So in such cases, I can go with one. Automatic task. Did you understand this? Let us see the example for the recursion function. The recursion function is nothing but, suppose I want to find out the factorial of the number. How to find out the factorial of the number? Calling the function itself, you can find out the factorial of the number. You can see this is a function we are writing. Function, what is the keyword I am using? Automatic. Then, what is the range is? This factorial is a function name. It declares the register of implicitly, internally, what size? 32-bit size. Then we are declaring the input. N is the input, 32-bit input. So write the begin and end. Then how to write the program for the recursive? Factorial of the number. If 4 is how to find out the factorial of the number 4 is, I can do 4 into 3 into 2 into 1. Correct. So factorial of 1 is nothing but what? 1. Factorial of 0 is nothing but what? Factorial of 0 is? Factorial of 0 is nothing but 1. So now we are checking if n is greater than 2, conditional statement. If n is greater than 2, what I want to do? Factorial. What is factorial is a function name. So I am performing this factorial operation. So factorial of n minus 1 into what? 2. If n is equal to 2, it is going to this if condition. If condition, what I am writing? 2 into factorial of what? 2 minus 1. So it is calling the function itself here. So factorial is equal to factorial n minus 1 into 2. Else what I should write? If n is not greater than 2, if it is 0 or 1, I should write what? Factorial is equal to 1, n and then end the function. So this is one example for what? Recursive function. Calling the function itself. So that what I can use the keyboard is nothing but automatic. In two places you are calling concurrently, then you can use the automatic keyboard. Did you understand this? And this is example already we did, task example. So full adder using what? Half adder. Full adder using the half adder. This already we have done this program. Now this is a program of, so using task, we are assigning the nipple. What do you mean by nipple is how many bits? 4 bits. So for 4 bits we are assigning the value to the 4 bits. You can see this is the task we are writing. Task name is what? Nipple. Then output is 4 bit. Input is also 4 bit. So we are using integer I. Then to write the statements of the task, begin and end. So n is equal to 0 initial. Now I am writing the for loop. For I is equal to 0, I is less than 4, I plus plus, begin. So if x of I is equal to 1, what I am doing? Incrementing the n value. N is equal to n plus 1, then end this, begin, in this task, begin, then end the task, end the module. So this we are writing inside the module. Module count underscore nibble. Inputs are input and outputs are n and x. Input is 4 bit x, output is 4 bit n. Then I am calling the what? This task always at the rate of x. Then this is a task name, nibble of n comma x. Did you understand? This is an example of the task. So this is an example of again function to find out the factorial of the number. Factorial of the number. So we are writing the function to this function 32 bit. What is a function? The register size is nothing but 32 bit. What is the function name is? Factorial. So I am taking the 4 bit input. Then I am using integer I in the for loop. Integer I begin. Initially factorial is equal to 1. For I is n, I is greater than 0. Then I am decrementing the I value. First it will take, suppose n is equal to 4, it will take the 4. 4 into 3 into 2 into 1. Factorial is equal to, first it will do 1 into 4. Again it will do 1 into 4 means 4. 4 is assigning to the function. Factorial. Again it will take what? 3. 3 into 4 into 3 into 2 into 1 it will do. Now I am calling the function in initial begin. I am calling the function by keeping n is equal to 3. So I am displaying function. Here I am calling the function factorial of the n. These are n with the 3, n with the 4, n with the 5, n with the 10. Did you understand? So this is a program used to find out the factorial of the number using what? Function. Try this. And then this is a function using task. Same program. Factorial of the number using what? Task. So task name is factorial. Input and output variables. Integer. So I am taking reg output is 32 bit. Then begin. Then initially reg underscore output is equal to 1. Then the same loop here, what I am using in the for loop, in the function I am using the same loop for, then I am calculating the what? Factorial of the number, then end the task, end the module, then I am calling the task with the different value. N is equal to 3, n is equal to 4, n is equal to 5 or n is equal to 10. So this is a factorial of the number using task. But this is not using recursive task. Correct? And calculating the factorial of the number using what? Function using loops. This is a program. This is a program of what? This is a program of what? Recursion. Calling the function itself. So this is a program we are finding out the factorial of the number using function, and this is using the task. Did you understand? So we have some examples. Can you write a program to all this? Okay, let us start from this example. This examples and function and task. So define a function to design the 8-bit function ALU. This program already we have done using case statements, if you remember, correct? Now I'm asking this used to do using what? Function. So define a function to design the 8-bit ALU that takes two 4-bit number A and B and computes the 5-bit result. 5-bit result out based on the 3-bit select signal. 3-bit select signal, ignore the overflow and the underflow. You can use the same code what we did for the what? Case statement to function the ALU, to do the ALU operation. But I should do this using what? Function. Can you write a program to this? If the select signal is 0, 0, 0, output is nothing but A. 0, 0, 1, A plus B. 0, 1, 0, A minus B. 0, 1, 1, division, modulus, left shift, right shift, and A greater than B should. Can you write a program using function? Write a program using function. How to write a program to this? You write a function. Okay. Can you write a function to this? Then we'll write the module. Okay. How to write a function? Function. Ledger 4 down to 0, correct? Then name of the function shall I take your ALU? Then input. Okay, input. Reg 3 down to 0. A comma B. Okay. input, right side, 2 down to 0. Okay, select. Then begin, right? Begin. Then case of what? Select. Case of select. Then 3 ticker or D0, correct? Again the decimal 3D0 case statement. ALU, right? It is going to return to what? ALU is equal to A. Now this is A. Again 3 ticker D 1 colon what? ALU is equal to A plus B, correct? Then what I need to write? 3 tick D2, this is A minus B. Next D3, what is this is? A divided by B. Then this is 3 tick 4 A modulus. Then 3 tick 5. This is nothing but what? Right shift by what? 1, right? Left shift. This is left shift by 1. Again, this is 3 tick 6. Right shift. Right shift by 1, then 1 is nothing but A greater than B. 7 is A greater than B. A greater than B. End the case. Then end the function. Begin. Then what I need to do? End the function. End the function. Did you understand? Now what I need to do here? Module TB. Module TB, then so I am modeling the ALU, right? So I can go with ALU 1 of A comma B comma, correct? Select comma out. Then here inputs are input 3 down to 0 of A comma B. Then input 2 down to 0. 2 down to 0 of what? Select. Then output rich, it is 4 down to 0 of out. Now what I need to do? I need to call the function. How to call the function? Like always, at the rate of what? A or select. Select.
अरे अब लगाने पर दे रही है यार, बनाने पर दे रही है, देखा ना चढ़ जाएगा सारा किला।
What I need to write?
बनाने पर दे रही है बस अपने ऊपर।
Out is equal to ALU of
सिंगल रूम तो कोई मिलेगा नहीं।
A comma B comma select.
आपको यहाँ नहीं मिलेगा। बोले कि बच्चा
A comma B comma select.
करने से क्या होगा?
Then I want to see all these operations.
कोई नौकरी करता है।
How to do that?
शुरू करे तो कुछ भी करे कहीं भी। हाँ प्राइवेट है गवर्नमेंट।
I can use one more variable. Then I can increment that.
बच्चे लोग बाहर हैं।
Okay,
कोई
here I am
जैसे
calling the
है,
function.
खर्चा
Out
तो
is
नहीं।
equal to ALU of
वो
A comma
खाने
B
का बता
comma
रहा है, कोई
select.
कॉलेज में पढ़ता है जी।
Then what I need to do?
है ना खुजाबा महीने
End the
का
always.
ये भी हमारा ऐसा
So end the module.
कुछ बोले हैं भाई अब तब
कुत्ते को खाता
The
है।
module.
कुछ
समझ
बोले
में आया?
हैं कुछ ही बोलो बता
तू क्या करेगा?
So
आज
that's
पूरा
confirm any syntax errors. This is clear. Now we wrote the design file.
अभी
Now what we need
टेस्ट
to write?
लेने के लिए कर रहा था गन फटरल होता
Because ALU I'm
है।
modeling
साला
here.
पढ़ता नहीं इसके लिए
So
एक
then
वो
I
रटते
can
जाए
go
ना कोड
module.
लिख के रख पड़िया
TV,
हैं
Rex,
थोड़ा कुत्ता दे
3 down to 0 of what? A comma B. Then
मैं अभी में कंप्यूटर की पूरी रट गई थी बात
Reg
मेरे सारे याद था
2 down to 0 of select.
ओह रिकॉर्ड हो रही है
Then wire 4 down to 0 of out. Then what I need to do? I need to instantiate this, right? LU1 DUT. Let us do the connection by default. Then what I'm going to do, shall begin to generate the input and then select line. Let us A comma B comma select. This is equal to dollar symbol. Let us make random. Then let me give the time. Then I'm going to display of A is equal to percentage T, comma B is equal to percentage D, comma select. Select is equal to percentage D, comma out is equal to percentage D. Now let us pass the argument A comma B comma select comma out. Then let me finish. Then I'm going to end. Then end the module. First let us run for any syntax errors. Now it is doing what operation is. Select line is 4. Let us print the select line is B binary. 100 means what operation? So 4 means modulus operation. 10 is 4. Sorry, A is 10. B is 4. A is 10 and B is 4. What is the 10 modulus of 4 is nothing but 2.
कागज
Did you
से
understand?
ना रे कालिया
Now how to check for all these cases?
फ्रीज में जाके रख दे, धक मत, फ्रीज में रख दे इसको.
How to check all these cases?
कहते रही है
If I repeat
Please,
this,
Mr. Ray.
it will repeat for a fixed number of times. What you can do? You can use the increment one more variable, increment, and then you can call the function. Each increment you can call the function, so that it will start checking for all the possible combinations. Did you understand? You can try for that. Write a program to increment and check the verify for all the cases. So here you should understand that how to write the function. How to write the function to perform the what? ALU. It will take 4-bit input AB and then 3-bit control signals. So then performing the ALU functions, 8 ALU functions. This is 0 to 7 is nothing but 8 ALU functions. Did you understand this program? So now can I ask you next program? Can you write a program for that? Can you do this program? Define a function to multiply the two 4-bit number A and B. The output is an 8-bit value. Invoke the function using stimulus and check the result. Invoke the function by using what? Stimulus and check the result.
देखा ये देख ले, यही होता है. तो खिला उसको और सांड की तरह. सांड नहीं बना तो
So how to write a program to this? It should take multiple of two 4-bit numbers. A is 4-bit, B is 4-bit. Result should be how many bits? 8-bit. So he's saying that invoke the function by using what? Stimulus, and then check the result. So how to write a program to this? So I should start with what? Module, right? TV, module TV, then so range 3 down to 0. I can use A comma B, then so range 7 down to 0. Shall I use the out? Correct? Next. Now can I write the function? Correct? Function. 7 down to 0, right? Result should be 7 down to 0. Shall I write function name is mul? Then input is what? Input writes 3 down to 0 of what? A comma B. Then begin and end. Begin end, and then let me write the end function. End function. What is statement I should write? Mul is equal to what? A into B, right? A into B. Now I need to invoke this in the word test bench itself. How to invoke this? Again go with always or initial begin also, right? Always, initial or always. Always at the rate of what? A or B. A or B begin. Out is equal to mul of A comma B. Mul of A comma B. Then I am going to end this. Then I am going to write what? Initial begin. Initial begin. Let us make A is equal to 5. B is equal to 5. Let me give some time. Then what I want to do? Dollar display of A is equal to percentage D, comma, B is equal to percentage D, comma, out is equal to percentage D. Then A comma B comma out. Then let me finish. Let me finish. I'm going to end the initial, then end the module. End the module. So I'm calling the function name. Now it should be 5 into 5 is nothing but 25. Did you understand? This is another program. Now shall we go to the next program? Can you see this? Define a function to calculate the factorial of 4-bit number. The output is 32-bit. Invoke the function using stimulus and check the result. So you should define a function to calculate the factorial of 4-bit number. The output is 32-bit. Invoke the function by using the stimulus and check the result. How to write the function to this factorial of the number? Can you write the function first for this? Function, okay. Function, okay. Integer, okay, he's talking about 31 down to 0. I can go with integer also. So let us go 31 down to 0. Let us like factorial is a function name. Then input 3 down to 0, correct? So let us take n. N is the input. Then what I need to do? Okay, I need an integer, correct? For if I'm iterating, I'm going to declare this as an integer. Now begin. Here what I need to write? Initially, I can make factorial is equal to 1. Then how to calculate the factorial of the number? For I is equal to, how to find out the factorial? Can you tell me what iteration I can do? Let us take I is greater than n. Okay. Initially, I is greater than n. Then what condition I can write? Phi is greater than n, it is going to for what? If 0 is first, it is checking 0 is greater than n. Then what condition I can write? I is less than 0, then I is equal to I minus 1, means it is taking it, suppose n is equal to 4. If n is equal to 4, it start with what? It should be I is equal to, shall I make I is equal to n, this is? No, 0 is not greater than n, equal to n, right? If I write like this, 0 is less than 4. When 0 is less than 4, what I want to do? Fact is equal to what? I want to do, suppose if n is equal to 4, 4 into 3 into 2 into 1. What to do? I less than, okay. I want to do 4 into 3 into 2 into 1. First I should take 4 and then 3, 2 into 1. I think this already we discussed this one, right? So factorial of the number. So let us take for I is equal to n. I is greater than 0, then I is decremented n. Did you understand? This is a program I can use, correct? I is equal to n. Then what? I is greater than 0, then I is incremented. Now let us begin. What I want to do? Factorial is equal to factorial into I, factorial into I, right? Factorial into I. What happens initially? Factorial is equal to 1. So when I is equal to what? N means what it will take? 4. So this becomes what? 1 into 4. Again I is decremented by what? 3. Again fact becomes what? 1 into 4 is there, 4 is there. Again 4 into 3. Again 4 into 3 into 2. Again 4 into 3 into 2 into 1. Now I am going to end this. Then what I need to do? End the begin, then end the function. End the function. So, but I should write the module to this, right? Write the module. So I should verify this using the stimulus. Module T. Rich. Okay, 3 down to 0. Let us take this is number. Okay. Rich. 31 down to 0. So let's take this as output. Out. Then what I need? I is required. So I am writing the function into to performing the what? Factorial of the number. Then this is a function I am writing here. And what I need to do? Let us call the function. Always at the rate of what? At the rate of number begin. Then what I need to do? Out is equal to what? Function name is factorial of number num. Then what I need to do? I'm calling the function, then end the always. Now initial begin. So let us make num is equal to 4. Give the some simulation time. Then print the result. Display of. What I want to print? So num is equal to %d. then out is equal to percentage D, then num comma out, then finish, then end the initial, then end the module. You understand? Now what is the factorial of 4 is 24. Let us print here 0D. This is 31 down to 0. Factorial of the 4 is 24. Now let us make num is 5. Factorial of the 5 is nothing but 120. Now num is equal to 5 is nothing but 120. Did you understand this program? Now let me give few questions to the assignment. Can you do those questions? Now we have done this. Define a function, calculate the factorial of the 4-bit number. And then I think this also we have done. Multiplication of 2. And then this third one we have done. Case using the, ALU using the function. Now can you try to find this? Define a task and compute the factorial of the 4-bit number. Same we have done using what? Function. So he is talking about here, define a task to compute the factorial of the 4-bit number. The output is 32-bit value. The result is assigned to the what? Out. After what? He is talking about after a delay of the 10 units. How to do? Output is assigning after 10 delay, right? As 10 when you are reading the task. Okay, you read the program to this. So this is one question, and this is next to last question. These two questions on task. Okay, this is the last question. Define a task to compute the even parity of the 16-bit number. Even parity means what operation? You can go with the XNOR operation. XNOR, the result is 1-bit value. That is assigned to the output after what? 3 positive edge of the clock. To assign this 3 positive edge of the clock, you can go with what? Repeat loop. Write a repeat of 3 at always first edge of the clock. Then you can assign the value. You don't understand? So write a program to these two examples. Okay. So with this, let us stop the task and functions, and then in the next session we'll begin with some useful modeling techniques, like how to create the user-defined primitives. We try to using the predefined primitives, right? What is the logic to define the predefined user-defined primitives? Some useful techniques like what is a force and release concept, then assign and deassign. Most of the useful modeling technique which we use in Verilab, we'll start discussing that in the next session onwards. Okay. So you worked few examples on task and functions, so which is available in the assignment questions also. To take up those assignment questions on the task and functions. Okay. From the next session onwards, let me start with so we spoke about 4 style of level of abstraction, like gate level, data flow, behavioral, then switch level. And then we understand how to model the digital circuits using all the 4 style of modeling techniques. And then we talked about what is meant by continuous assignment statement, what is procedural assignment statement. And then we work on various concepts, correct? So then we'll understand that in the next session onwards, what are the useful modeling techniques are there in Verilab. Okay, how you can override the parameter, what are the overriding parameter techniques are there. Then we talked about enable and disabling of the block, correct? So how to enable the disabling of the blocks, like assign and deassign, some concepts